Hello, my people. I hope we're doing well. I'm gonna go ahead and make a video of me walking through this first quiz that you took for me and that I've just graded, because we don't have an opportunity to go over it in class because, we're not together. And I think it's going to be helpful for you, for me to walk through this so that I can give commentary and stuff like that. I already have the answer key, the sort of tabulated and weighted answer key that has all the pointing and everything like that on it scanned, and I will probably post that as well. But I just think it would be important for us to sort of walk through this, and then I'll sort of offer some reflections in the midst of it and a couple of reflections at the end. Now, here is the first page. Now it says determine two coterminal angles, one positive, one negative, for the given angles. Be sure that your answer is given in the same units in which the problem was posed, radians to radians, degrees to degrees. Now, most of you got this just fine, okay? Some, I think, they didn't do enough practice because they still seem to be unfamiliar with radians. Like the degree stuff y'all got down just fine, okay? But coterminal means around again, right? Has the same terminal side. So here we need to add 360, and that winds up being 130 degrees. And this one winds up being minus 360, so minus 590. There are actually a couple people in the computation forgot the negative right here. And that's just careless, and I understand that. But I will continue to count points off for things like that, largely because I want to train you to actually remember those things and to sort of strive after the precision that is required to get even the small little details correct, all right? Now over here, a lot of people, you need to remember that a full time around is 2 pi. And therefore, if I'm going to add 2 pi, I need to add 6 pi over 3, which is sort of unreduced. And then I need to subtract 6 pi over 3. Now, a lot of y'all got this correct. And those are the two answers for that. Now, when it came to complementary and supplementary, that's where people kind of went a little bit off the rails, okay? Now, complementary obviously adds up to 90 degrees. Now, the degrees one was just fine. And of course, in order to get to 40, you would add 3, and then you need 50 more, so it's 53 degrees. Please remember to put the degrees. Those are the units, okay? Now remember, you don't have to put units after radians because as long as it's in the pi form, it's kind of implied. And second of all, radians really aren't a true unit, so they're sort of a pseudo unit, right? Because they simply measure the portion of a full revolution. Now, supplementary adds up to 180. So you would just take your complementary angle and just add 90 degrees to it, right? 143 degrees. Yay, okay? Now, those are just fine. Some people, when they got over here, started thinking about 2 pi. Well, 2 pi is all the way around, okay? And so you're not dealing with 2 pi right here. In complementary, you're wondering, what must I add to this? Like, plus blank equals, well, for complementary, this is going to be pi over 2. So in order to find that blank, it's pi over 2 minus 2 pi over 5. Get a common denominator. This is 5 pi over 10 minus 4 pi over 10, and that's pi over 10, okay? Here it's pi, because pi is the same thing. Pi radians is 180. Now this one is a little bit easier because you don't have to change this one. You simply have to realize that pi is 5 pi over 5, and this is 3 pi over 5. Now, some people gave me 3 pi over 5 for the complement and 8 pi over 5 for the supplement. and you were basically doubling the sums that I was looking for. Complementary angles don't add up to pi. Complementary angles add up to pi over 2. Supplementary angles don't add up to 2 pi, they add up to pi, okay? Now when we get down here to the conversion, radians to degrees, okay? We want to multiply this by 180 degrees, remember the units, over pi. Be careful when you're canceling out. Some people, like over here, canceled out 8 without canceling anything from the 180. Well, first of all, 8 doesn't go into 180, 4 does, okay? So if you basically, you know, take 4 into there, of course, in order to divide by 4, you half it and then half it again, and that's 45 degrees. Well, 3/2 of 45 degrees is 67.5 degrees. Here on this one, some people gave me decimals. I never did that in any of the examples. I want an exact answer for this, not an approximate. Okay? So when I'm converting this to radians, all of a sudden I recognize there's no common factors here because 53 is actually prime. But those units do cancel out, and I'm left with 53 pi over 180. And yes, you just leave it like that, okay? Now, this next one, some people had a problem with, largely because number 7 can actually be done in several different ways. I don't know, I may get bored and not do all of them for you, but let's go ahead and just draw a circle. If you want to use a compass, that's fine. If you don't want to draw a circle, you just want to freehand it, that's fantastic too. But I'm kind of, you know, a stickler for precision. So, and so basically we have a circle, okay? It says a bicycle wheel with a radius of 13 inches. Now, part of the credit that I apportioned for this was based upon mining the correct information out of the question stem. Now, a radius of 13 inches was part of that information. And it turns with an angular velocity, that's omega, of 3 radians per second. Now, some people just could not get over the fact that the radians measurement was not given in terms of a pi measurement, but in terms of an integer. It's still omega whether there's a pi in there or not. So there were people who tried to take 3 radians per second and multiply it by some multiple of pi. No, okay? Now from here, we know that my linear velocity, my linear speed, is r omega, right? You have omega, you have r, so automatically you should be thinking about that right there. But that's not what it asks. It says find the distance traveled, okay, by a point on the bicycle tire in 1 minute, okay? Okay, so basically that's the linear distance. It goes around and around and around and around. That's a linear distance, not linear speed. You're looking for arc length. You're looking for s, not this. Well, s is equal to r theta. Okay, well, here's the thing. Omega over here is theta over t. That can become theta is equal to omega times t, because guess what else you have? In 1 minute, you have t is equal to 1 minute. Now, granted, that is a different units right here, so t is also equal to 60 seconds. So you could get theta simply by multiplying omega, which is 3 radians per second, times t, which is 60 seconds, and your theta would be 180 radians. now that you have radians and radius, you can go ahead and put S is equal to 13 inches for your R, and then 180 radians for your theta, and that winds up being 2340 inches. Now, you can convert that into feet. You weren't asked to, but that's one way to do that problem. Okay? Now, you didn't have to do it that way. There are actually a couple of other ways that you could do it. Let's go ahead and look at those. Now, let's say that you have V is equal to R omega. Now, you could get V is equal to R omega. We've already talked about that. Your R is 13 inches, and your omega is 3 radians per second. That means that you, because radians is sort of a pseudo unit, it kind of disappears, you have 39 inches per second in linear velocity. Now, from there, you know that, of course, it's going around and around and around the circle, but if you were to lay it out flat and actually think of it as linear rather than around and around and around, all you really need to do is go back to that really familiar formula of distance equals rate times time. And your rate, of course, is your 39 inches per second. Your time was 1 minute or 60 seconds. And guess what? That product is also 2,340 inches. Okay? But there's still another way that you can do it. And I didn't even think about this way until somebody decided that they wanted to take their omega of 3 radians per second and turn it into something that we didn't actually designate a variable for, but which you could. They wanted to turn into revolutions per minute. And that's fine. You can do that. You set up one of these little charts and you have 3 radians per second, and you have 60 seconds per minute, and then you have 2 pi radians per 1 revolution, right? And if that's the case, then basically the seconds cancel out with the seconds, the radians cancel out with the radians, not that they really have to, pseudo, right? And what you get here is you get 90 over pi revolutions per minute. Well, that's really not all that bad. I can handle that. Now remember, don't approximate, leave it like that. But here's the thing. If I have a radius of 13 inches, then I have a circumference of 2 pi r, right? And therefore my circumference is 26 pi inches. Well, because it's the entire circumference, that is actually the same thing as, hey, there are 26 pi inches per revolution. So if I just multiply these two things together, I get 90 over pi revolutions per minute, and I get 26 pi inches per revolution, and the revolutions cancel, the pi's cancel, and I'm left with 2340 inches per minute, which is of course part of the question stem, right? In 1 minute. So, basically the minutes fall out because basically you just multiply it, times 1 minute, and you get again 2340 inches. So there are several ways to get around this and actually arrive at the correct answer. And I don't really care how you go about it. All 3 of those are legitimate. I think this last one is probably the more creative one, but also the most circuitous and the most work. But, who am I to judge? I'm only the teacher. Okay, let's go ahead and take a look now at 8. Oh, by the way, that's not your answer. I've said again and again and again, okay, maybe I've said it 3 or 4 times, not again and again and again and again and again. If I ask the question in sentence form, you answer it in sentence form. There was only one person who gave me both answers in sentence form. So you would basically write out a sentence, the distance traveled by a point on the bicycle tire is in 1 minute is 2340 inches, and then you would box in that answer. All right, let's go down. The second hand of a clock is 10.2 centimeters long. Sorry, I'm using the cup because I actually don't have a really good compass at the moment. My compass kind of wore out. And I just, haven't gotten around to buying a new one. So I have 10.2 centimeters. Like, that's my radius, okay? And, that's the second hand, and you're thinking about the tip of the second hand as it goes around the clock. Now, part of the difficulty of this problem is the fact that basically omega is implied because it's a clock, right? And you get 1 revolution per minute. Well, 1 revolution per minute is 2 pi radians per 60 seconds, okay? And that means that what I get is I get an omega of pi over 30 radians per second. Oh my gosh, look, I have R. I have omega. I'm being asked for V. V is just R times omega, and I get 10.2 centimeters times pi over 30 radians per second. Now the problem here is that you have a decimal and a fraction. Oh no, that's just terrible. I wouldn't want to ask you to turn a decimal back into a fraction. That would just, the humanity. Oh wait, yeah, I could ask you that. But actually, most people gave me a decimal answer on this one, and that was actually just fine, because for something like this, the decimal is appropriate. And actually, I basically approximated some of these word problems and gave them to you as an answer. Now, if you actually do keep it, remember that this is basically 102 over 10, or 51 over 5. And basically that basically becomes 17 pi over 50 centimeters per second, which approximates to 1.068 centimeters per second. 3 decimal places. I don't approximate anywhere in the intermediate steps. I approximate once at the very end, and it's to 3 decimal places. 3 decimal places. 3 decimal places, okay? And then, of course, you would author a sentence because it was asked in sentence form. Now, that takes care of the sort of pre-trig stuff. Let's move on to the trig stuff. Now, the terminal side of the angle that passes through 2, -7. This didn't wind up being too difficult for most people. You know that 2, 7 is going to be in the 4th quadrant. You can draw yourself a little picture over here if you want. Do that and tick, 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 and that's 2, and that's -7. And over here is not a decimal approximation. It is root 53, okay? And that, of course, is theta prime. That is your reference angle. And you would give me all of these ratios based upon those 3 values. Not an approximation of those values, those 3 values. And so that's -7 over root 53. And of course, you would probably rationalize the denominator, and most of you did, and that's great. But basically, you have opposite over hypotenuse, hypotenuse over opposite, sine and cosecant. Cosine is 2 over root 53. And then secant is its reciprocal. Tangent is -7/2, and cotangent is -2/7. And there you go. Now, on this next one, cosine is equal to 3/5. Now, cosine is positive in the first and the fourth quadrant. There were some people who gave me all positive values down here. I find that interesting since it specifically tells you that tangent is negative. If cosine is positive and tangent is negative, you are again in the fourth quadrant. Okay? And I'm not doing this to scale, I'm just trying to quickly sketch something so we can actually just keep going. This is 3, this is -4, and this is 5, right? Because 3 to 5, adjacent to opposite, that's going to be a 3, 4, 5 right triangle. This one was already given to you, so I actually didn't count that as having any points. Thankfully, nobody gave me an incorrect answer there. -4/5, this becomes 5/3, and this becomes -3/4, and you just read them right off of the triangle. Now, the next one. This one, actually, I was happy with the fact that everybody pretty much did what they should have done in this one. I explicitly said quadrant 3, so that probably wound up being a little bit easier. There were some people who, for some odd reason, thought that if I have 3 and I have -1, that this over here is √2, which kind of odd, because it's 3 squared minus 1 squared. So this is √8. This is 2√2, but it's not just 2√2, it's -2√2, because in the third quadrant, both x and y are negative. So if you missed the negative, you lost points. If you gave me √2 instead of 2√2, you lost points. Now this one was already given, but this, being -1/3, should have been relatively easy. Opposite over hypotenuse, -2√2/3, and of course this winds up being -3√2/4 when you rationalize the denominator. This is 2√2 because it's -2√2 over -1, opposite over adjacent, right? Because this is your theta prime. And this winds up being 1 over 2√2, and when you rationalize the denominator, you get √2/4. Now, except for just a couple of, things, most people did pretty well on that, and I was happy. This next one, some people just plumb forgot to look at the identities. We did a couple of examples of how to find the rest of the values using identities rather than using the triangle. If you use the triangle, I didn't give you any points. That's why it says you must use identities to receive credit. Okay? Now, sine, and I'm looking for cosine. Well, sine squared theta plus cosine squared theta is equal to 1. When you're doing this, you need to show me the identity first. And then, of course, this is sine theta squared, right? This is lazy man's notation. And I wind up with 3/4 squared plus cosine squared theta is equal to 1. Now that's 9/16. And when I subtract it from 1, I'm going to get cosine squared theta is equal to 7/16. Now, some people made the mistake in terms of the subtraction. Some people made the mistake when they actually took the square root. I mean, there were a whole host of problems that were going on here. When I take the square root here, I need to remember that there is an ambiguity as to whether it's the positive or the negative. I didn't take any points off if you missed the positive and the negative, just because so few people actually were getting, anywhere close to the right answer. Now that I have cosine and I already have sine, I know that tangent of theta is equal to sine over cosine, and therefore it's equal to 3/4 over plus or minus √7/4, so you get plus or minus 3 over √7, or plus or minus 3 √7/7. And that is, of course, what should have gone here. Now, some people just put 3/4 right here, but I need to see how you arrived at that. Remember, a quiz and a test are not, can you get the right answer? It's can you communicate to the teacher that you got the right answer for the right reason, which is why if you left out steps, I didn't give you any credit for it. You need to tell me sine theta is equal to cosine of 90 degrees minus theta. Don't leave it implicit, make it very explicit. And therefore, if sine is equal to 3/4, then so is cosine of 90 degrees minus theta. That is the cofunction identity, and this is 3/4. Now, all of that, that's basically what should have gone on in this quiz, okay? Let's go ahead and just feedback on quiz number 1. I went ahead and typed this out. First of all, guys, when you get my quizzes back, you may go, wow, that's harsh. I'm not trying to be harsh, but my comments on your quizzes will not be sugar-coated, okay? If I have no idea how you got a particular answer, I'm going to tell you. I have no idea how you got this particular answer. If you didn't follow instructions, I'm going to tell you, you didn't follow instructions. If you didn't follow instructions on giving me an approximation to 3 decimal places, I put it in all caps, and I probably underlined it a couple of times, okay? I'm not trying to be mean. I'm trying to catch your attention and make it memorable so that you stop making these mistakes in the future, especially the silly ones, okay? I will always react more vehemently against the silly mistakes, the ones that you should know better. Does that make sense? If you're just making careless errors like forgetting a negative, I'm not gonna have a problem with that. If you do something like distribute an exponent across a sum, you might find footprints on your quiz from where I've thrown it on the ground and jumped up and down on it. Now, the second thing is notation. We already talked about how these things are pieces of communication. The way that people communicate in math is by notation. Okay, that's at least one of the ways they communicate. That means your notation needs to be precise. Okay, I'm going to give you an example, and this basically is what happened on the last page for some people. Okay, they put, cosine doesn't equal anything. Cosine is an operation. Cosine needs to be performed on something. Cosine theta is equal to 4/5. That communicates something to me. Cosine is equal to 4/5 that's like saying multiplication sign is equal to 4/5 or logarithm is equal to 4/5. Those are strokes of the pencil that designate notation, okay? That designate an operation. You need to not only be precise but comprehensive with your notation, or you will lose points, okay? You need to communicate fully and clearly with me, and I'm going to try and emphasize that, because I don't want you to get all the way to May, take the AP exam, and lose points for something as silly as sloppy notation. Not on my watch. Third thing, scanned PDFs. Some of y'all are scanning your stuff to me in color. And because you're scanning it to me in color, when it prints out, it's dark gray. And when you get it back, after I've done the correction, I've graded it and I've rescanned it with my ink and everything all over it, you're going to see how dark it is. You need to be scanning to PDFs. You need to be scanning to black and white PDFs. That means that if you're not currently scanning to black and white PDFs, you need to go into the settings and set it to black and white. If the background of your scan is not as white as this piece of paper, you need to do it again, okay? And it needs to be a single document. I don't want 5 different PDFs. I certainly don't want 5 JPEGs. I want a single document with a white background, 5 pages or all the pages in a single PDF document, okay? It's about following instructions, guys, okay? I need you to follow instructions because when you don't, you make more work for me, and your teachers already work hard enough. Approximations. We talked about this as we went through the quiz. I need you to approximate only on questions where you are specifically asked to or where you know it is appropriate, because the questions that I did as examples have approximations for answers. If I didn't approximate on a problem like that, or you know good and well that you shouldn't approximate, don't approximate. Now, when you're doing a long problem, especially like a word problem, you do not approximate in the midst of the problem. You carry exact values all the way down into the bottom, and you approximate once at the very end. Otherwise, you have an answer that is an approximation of an approximation, and if you are 2/100ths away from the right answer, the AP graders will count it wrong. Okay? And you always approximate to 3 decimals. Not 2, not 4, not 3 significant digits, 3 decimal places. And that's there because the AP exam asks you to approximate to 3 decimal places. Please do so. Now, most of y'all did pretty well in this test. That was kind of expected because it actually is kind of rudimentary stuff. I understand that there are some things that are going on this summer that are not summer trig. Some of y'all have jobs, some of y'all had trips and mission trips planned and stuff like that before. But there are 2 purposes to this course. One of them is to teach you all the trigonometry that you need to be a successful calculus student. The second one is to determine whether you will sink or swim if you take calculus. If you do not score well during this summer trig, I will recommend to the administration that you not be placed in my class. Calculus is hard enough without being deficient in trig. And I'm also going to ask you guys to be self-reflective. Calculus is difficult. This is a college level class that I will teach at one pace, my pace. And if you don't keep up, you're going to be incredibly discouraged all year long. And I quite frankly don't want to see that, okay, for your sake. So please, if you're going to work hard and and here's what work hard means. Do the work until the work is done. You don't quantify hard work by, well, I worked for 2 hours last night. I don't care. If you didn't work long enough to get the work done, then you didn't work hard, okay? If you're willing to do the work, if you're willing to do what I ask you to do, there should be no reason why you should not pass the AP exam in May. If you don't do what I ask you to do, if you don't do all the necessary work, and you quantify hard work as, well, I did it for 45 minutes until I fell asleep last night, then that's fine. You can come and have a ticket to the show, I guess. You're not going to do well on your report card, and you're not going to pass the AP exam at the end of the year. So I just want y'all I just want to be very honest about that. I want to make sure that you understand that there is a second purpose to this class. I will go ahead and post this document as well alongside the key and a link to this video. If you have any questions on my expectations or anything like that, please do let me know. I'm not trying to be the bad guy. I'm trying to make sure that you don't get into a situation where you are in over your head and you don't realize it until after the drop date. Because that's just no fun. Feeling like you're drowning all year long and you can never catch up is just not fun at all. And I don't enjoy watching students do that. And I'm going to try and not set you up for failure, and I ask that you not set yourself up for failure. So that's kind of the long and short of it. If you have any questions, shoot me a message. Bye.